Today's topic is chemical bonding. We will study about the basics of chemical bonding. In this, we are going to study about the what is the chemical bond, what are the types of chemical bonds. Okay, so first of all, when you take what is a chemical bond, it is the force which holds two atoms together in a molecule. Say, for example, if you take the molecule HCl or you take the molecule water. So here the H and Cl, they are held together in this molecule by certain force of attraction. So that force of attraction is called as chemical bond. Similarly, in water, the oxygen, hydrogen and hydrogen, they are held together by some kind of force of attraction. Again, that is also a chemical bond. Not only this, you take our table salt, sodium chloride. So some kind of force of attraction holding them together. So that is a chemical bond. So if you define the chemical bond, the force of attraction which holds atoms together in a molecule. So that will be the chemical bond. So how the chemical bond is formed between the two atoms? There are two ways of forming the chemical bond. One, transfer of electron. Always, whatever I'm talking the electrons, those will be the valence electrons. Transfer of electron or sharing of electrons. So these are the two ways by which a chemical bond can be formed. Now this is how a chemical bond forms. But why a chemical bond is formed? Right? Very simple. Always the atoms combine together to become stable. So the stability, you know already, either duplet rule or the octet rule. We already studied about these things. Octet rule means every element wants to attain 8 electrons, except certain elements which want to attain 2 electrons in their outermost shell, like they want to attain the electronic configuration of helium, like hydrogen or lithium, beryllium. But all other elements, they want to attain 8 electrons in their outermost shell. So that is called as octet rule. A chemical bond is formed to attain stability. That's it. Now let's see the types of chemical bonds. The first type of chemical bond is ionic or electrovalent bond. So how it is formed? It is formed by the transfer of electron. So how the electron transfer is happening? So there will be two things. One, always in the ionic bond, there will be a metal and a non-metal involved. This is the easiest way to identify it. So metals which are having the valence electrons 1, 2, 3 and non-metals having the valence electrons 5, 6, 7. Okay, these involved in the formation of this. Metals lose electrons. Meanwhile, non-metals gain electrons. So once metal lose electrons, they will form a positively charged ion which we call as cation. Non-metals, after gaining electron, they will form negatively charged ion which are called anion. This is positively charged ion, this is negatively charged ion. So therefore, ionic or electrovalent bond is present between the oppositely charged ions. So you know, oppositely charged ions attract towards together, like charges repel each other. So what kind of force exists between the opposite charged particles? Electrostatic force of attraction, which is very strong force of attraction. So you can define ionic or electrovalent bond as it is formed by the transfer of electron by one element, that will be metal, to the another element, that will be non-metal, and the force of attraction which holds the two ions will be electrostatic force of attraction. So that is called as ionic bond or electrovalent bond. The compounds are called as ionic or electrovalent compounds. So example, you take NaCl. Sodium is metal, chlorine is non-metal. So sodium will donate its electron to chlorine. Calcium oxide, calcium is metal, oxygen is non-metal. Calcium will transfer its electrons to oxygen. Magnesium oxide, magnesium metal, oxygen non-metal. Magnesium will give its electron to oxygen. In this we are going to study about electron dot diagram, which I will do separate video. Okay, so what are the conditions for formation of ionic bond? So metals should have low ionization potential. Low ionization potential means they will easily lose electrons if they have low ionization potential. Non-metals should have high electron affinity. If they have high electron affinity means large amount of energy is released when they accept electron. It means they readily accept electron. And one more thing, the difference in electronegativity should be large. So if you say sodium and chlorine, electronegativity difference is large, then it will favor the formation of electrovalent bond. So these are the conditions. Next point is electrovalency. You know already valency, right? Valency is nothing but the capacity or combining capacity of an atom of an element. So when you come to particularly about electrovalency, from now onwards you have to say that the number of electrons lost or gained by an atom, and since here losing or gaining of electrons is there, we usually show the plus or minus charge for that. Say for example, sodium, electrovalency of sodium is +1 because it loses 1 electron. Chlorine, electrovalency of chlorine is -1 because it accepts 1 electron. Okay, so this is a simple electrovalency. If you take calcium, its electrovalency is +2, oxygen electrovalency is -2. Calcium loses 2 electrons, oxygen gains 2 electrons. Okay, next type of bond is covalent bond. So covalent bond is found by mutual sharing of electrons by two atoms. Say for example, hydrogen molecule you take, hydrogen will have 1 electron in its outermost shell. So both will need 1 more electron to become stable. So this will follow the duplet rule. Okay, so here what happens, this hydrogen will give its 1 electron to this will give its 1 electron to this, means they will share 1 electron with each other. So how many electrons are shared? 1 pair of electron. So mutual sharing, both are sharing. Okay, so this type of bond where the mutual sharing of electrons occurs between the two atoms is called as covalent bond. If you see the types of covalent bond, we have 3 types: single covalent bond, double covalent bond, and triple covalent bond, depending upon the number of shared pair of electrons. So if there is only 1 pair of electron, means there will be 2 electrons, okay, shared, then it will form a single bond. Example, hydrogen molecule, chlorine molecule, okay, you can also write bromine molecule. So these all, a line represents the covalent bond, a simple line represents the covalent bond. Double bond, 2 pair of electrons are shared between the 2 atoms. For example, oxygen. So here if you see 2 bonds, 2 lines I have written, means double bond. 2 pairs are shared by the 2 atoms. One more example, ethene we can give, CH2 double bond CH2. So there is a double bond between carbon and carbon. Triple bond, 3 pair of electrons are shared between the 2 atoms. Example, nitrogen. So 3 lines represents the triple bond. and ethyne you can give CH1 2 3 CH. So this is a triple bond. Okay, so these are the types of covalent bond. Next, the compound which has the covalent bond or which is formed by the mutual sharing of electrons between the two atoms is called as covalent compound. We have two types here. So based on the electronegativity difference, so you might have already know this. One is non-polar covalent compound, another will be polar covalent compound. Non-polar and polar. Polar means two poles are formed. Non-polar, the molecule is not forming two poles. Like for example, you take HCl. So the electronegativity difference between hydrogen and chlorine is more. So the electrons will be pulled by the chlorine. So therefore, when you check its structure, it will be the pair of electrons will be towards the chlorine. So because of this, there will be a formation of slight positive charge or fractional positive charge on hydrogen, fractional negative charge on the chlorine. Means you form the two poles, positive pole and negative pole. Such compounds are called as polar covalent compounds. Non-polar means the electronegativity difference is minimum or it is zero. For example, H and H. Both are same atoms, no electronegativity difference, no formation of two poles. Similarly, CH4. Again, carbon and hydrogen difference is very less, electronegativity difference. So it is also a non-polar compound. Okay, so these are the types of covalent compounds. Just like electrovalency, there is a term called as covalency. What is covalency? The number of electrons shared by an atom in covalent compound. That will be the covalency of that particular atom. For example, here H and H both are sharing one electron, so both have the covalency 1. Oxygen, 2 bonds, so both are sharing 2 electrons, so therefore covalency is 2. Nitrogen, 3 bonds, so the electrovalency is 3. Carbon, if you take methane, it has how many? 4 bonds, means it is sharing 4 electrons, so the covalency of this is 4. So it is just nothing but what are the number of covalent bonds around the given atom, that will be its covalency. The last type of bond is coordinate or dative bond. So what is coordinate or dative bond? Here again there will be sharing of electrons. You can also call this as one of the type of covalent bond. Sharing of electron, but what is the difference? There will be two things. One will be donor, another one will be acceptor. So the donor will give the 2 electrons to the acceptor. Here there is no mutual sharing, it is just the sharing of electron given by the 2 electrons are given by the only one atom, but shared by both the atoms. Say for example, donor can be the one which has the lone pair of electrons. The donor will be, it should have one pair of electrons which is ready to donate. Acceptor should be short of a pair of electron, means it must need 2 electrons, not 1, 2 electrons. So for example, water you take, H2O. So you know oxygen will have 2 lone pairs, so it can donate both any one lone pair. So it is a donor now. Acceptor, I will take H plus ion. So H plus is short of 2 electrons. So what happens? Water will donate its 2 electrons or a lone pair of electrons to the hydrogen, and a bond is formed between water and hydrogen, and the molecule also you will see here H, H and this H, and this whole thing will still have the plus sign. Okay, so this bond, what I have denoted here with an arrow, that will be called as coordinate or dative bond. So always coordinate dative bond is represented by the arrow. The arrow starts from the donor, ends at the acceptor. One more one more example, ammonia, which where nitrogen has the lone pair of electrons. Again you take the H plus, the nitrogen will give both of its electron to H plus. So what you will get here, N H H H, and one arrow mark you have to write like this, and plus. It forms the ammonium ion. This is hydronium ion. So ammonium ion and hydronium ion, they contain coordinate or dative bond along with the covalent bond. A simple line is covalent. So these are the examples of compounds having both coordinate bond as well as covalent bond. Okay, so this is about the chemical bonding concept. So this the electron dot structure in the chemical bonding concept is little big, so I'm making a separate video for that. So until then, take care, subscribe the channel, share the video. Thank you so much.